Hi guys, so today we're going to be looking at 6.5 Properties of Logarithms Part 2. So, for today we are going to be looking at specifically change of base formula. If we have a, b, and c that are positive real numbers, where our b value is not equal to 1 and our c value is not equal to 1, then we can have the following formula. So if our log has a base of c of a, then I could separate it, where a would go on the numerator as log base b of a, and our base is going to be my denominator, log base b of c. We can also rewrite this as log base c of a, where you have log base a, or log of a dividing with log of c. We can also rewrite it in the ln format as ln a of ln c. Now, reason why we might want to do this is because of the following examples. So, if we're asked here to evaluate log base 3 of 8, and that's all we're given, we can use the common logarithms to help us solve this equation. So, I'll start off first with, I'll start off first with the problem. We have log base 3 of 8. So if I wanted to solve this, I can get log of 8 dividing with log of 3. And if I know what log of 8 is and what log of 3 is, which ends up being log 8 gives us 0.9031, and log 3, that gives us 0.4771. Then I can divide the two together and get my final answer, which is going to be 1.893. Same thing again, we can evaluate the log base 6 of 24, and we can also use natural logarithms instead. So if we're using natural logarithms, we have here log base 6 of 24. I can separate them as ln 24 over ln 6. And if I were to calculate ln of 24, I get 3.1781, and this is over ln 6, which is 1.7918. And then last thing to do, just to divide it. So I get when I divide, I get 1.774. And so that would be my final property that we're going to be looking at. And so I'm going to be using the properties that I have based off of the properties of logarithms, where we have the change of base formula. We also had the rewriting logarithm expressions. The properties are the product property, quotient property, and power property included with the change of base formula. We could try out a real-life situation. So, for a sound intensity in watts per square meter, the loudness L of I of sound in decibels is given by the following function. L of I is equal to 10 log I over I-O, or like a second I-O, where I-O is the intensity of barely audible sound, about 10 to the power of negative 12 watts per square meter. An artist in recording studios turn up the volume of a track so that the intensity of the sound doubles. So how many decibels does the loudness increase? So important parts of this is that we have our formula, first of all, which is L of I equals to 10 log I over I-O. And so then it also tells us here that, an artist in the recording studio turns up the volume of a track so that the intensity of the sound doubles. So we started off with our regular soundtrack, which is L of I. And in our other soundtrack, it doubled. So we have here L 2 times I, right? We're saying it double, so we're going to double our function. how many decibels does the loudness increase? So if we're looking at the difference in how much it increases, I am going to be finding the difference, which is subtraction. So all I'm going to do here is rewrite my function. I have here 10 log, and again, because we're doubling it, I'm going to write that we have 2i over I-O, and this is subtracting with our regular function, which was just the log 10 times log I over I-O. Okay. Once I do that, I do see that I could probably factor out the 10 from both of these terms. So I will get the 10 and factor it out, put it on the outside, and on the inside I'll just leave log 2i over I-O minus log I dividing with I-O. Once I do that, then the last step is to continue to expand it, because if you expand it, you're going to notice that something will cancel out in the end. So I know that 2 is multiplying here. 2 is multiplying with our I over I-O. And so if they're multiplying with each other, based off our property rule, we know that I can expand this by adding log 2 with the log I of I-O over I-O. And this is subtracting with log I over I-O. And when I do that, I can actually cancel out my 2 logs here with each other. And so I would be left with, oh, and I need to drop down the 10. I would be left with, and I'll move this to the left so that I have more space. So in the end, I will be left with 10 parentheses log of 2 as my final answer. And so the loudness increased by 10 log 2 decibels, which is about 3 decibels in total. Okay, so hopefully this helped. Good luck.